week 11, last week of this course, prior to the exam. Okay, so what I'm going to start off with today, I'm going to start off with giving you guys some information about the final exam. What we're then going to go into is our next topic, which is on value engineering. So our last three topics, re-engineering, concurrent engineering, value engineering, we're kind of taking all the information that we've talked about in the course and we're starting to bring it together. And then the last thing which I want to go over is that Toyota case study which I assigned to you guys last week. Okay, so in terms of the final exam, since I'm only counting 2 out of the 3 exams, the final exam is optional for those people who are satisfied with their grades to date. What I'm going to be doing in terms of the quizzes, I'm only going to be counting your highest quiz mark. So go ahead, calculate whatever you guys believe your mark is. And then based on that, if you choose not to write the exam, if you can let me know by end of day Thursday. For those people who are writing the final exam, the format of the exam or the content of the exam will be based on the last 3 lectures, the re-engineering, the value engineering, the concurrent engineering, and will require you to be familiar with all the information that was talked about in class, including the case studies and additional readings which I assigned. And the format will be 3 long answer questions. This portion or this last third of the course was not calculation based, so most of the questions you can expect a similar format to what you saw on the first midterm. Any questions?
If you do write your final exam and it goes down,
I'm still only counting the 2 highest.
the 2 best exams.
Yeah. But I know that some of you guys have other exams out there, so if you guys want to make the decision to opt out, then that's okay as well. Yes.
How can we get all quiz marks?
Yeah, so I'll be posting. I've been marking midterms for the last, I don't know how many weeks, so I will be posting them this week. Okay. Okay. Any other questions?
So if you don't make a final, how many breakdown?
So the breakdown doesn't change because I'm only counting 2 exams. Each exam is worth 45. Your quiz mark, I'm only counting the best one, that's worth 10. So that makes up the overall 100%. Okay. Any other questions on this? Going once, twice? I'll definitely try to put it up. Okay. Okay, so moving on to our topic for today, we're going to talk about value engineering. So value engineering, there's a little bit of a technical portion related to it, but at the same time, the topic is overall more business related. So the last 3 courses have had a little bit of a technical component or technical aspect and have been mostly OB, mostly more management related. So when we talk about value engineering, what do you guys think of? What are some of the things that come to mind when we talk about value engineering?
Value you get out of a product. What's its value?
So are you getting the bang for your buck? Like are you getting the most value for what you're paying for? Okay.
The value of business.
Of that particular product in the business, okay. So what do you mean by added value? Guys, can you please stop talking so those who want to listen can hear?
For example,
features, better quality?
Whatever way we get money, better.
Okay. So all the responses that I heard on the right track. So before we talk about what value engineering actually is, let's talk about what it's not. So in general, and value engineering does not necessarily mean cost cutting. So it doesn't mean reducing costs out of your current operations. It can, some of the actions done as part of value engineering can lead to that, but it's not specifically cost cutting. It's not design review. So you're not trying to review your design to figure out how do I make it better, how do I, add more features in. That's again another part of it, but that's not what value engineering actually is. It doesn't mean we're trying to eliminate projects from our organization either. Sorry. Can you guys see? Or okay. It doesn't mean scope reduction, quality reduction, detailed cost estimating, or it does not mean redesign of your overall product. So, according to an organization called SAVE, there's actually a society called the Society for Advancement in Value Engineering. If you Google it, you'll be able to find their website. The value methodology, which is another term used for value engineering, what it means is it's a systematic and structured approach which helps to improve projects, products, services, what have you, by achieving a balance between the required functions, performance, quality, safety, scope, etc., with cost and other resources that are needed. So basically, once you have the best balance between the resources needed to create your product or service and the amount of money that it's costing you, you should be able to deliver maximum value to the overall, to the end client. So what value engineering is, it's essentially an organized study of functions that's used to satisfy user needs with quality products at the lowest lifecycle cost through applied creativity. So what we want to do, we want to provide a solution, a product, a service, whatever it is, that meets our customers' needs, that solves the problem that we're trying to solve at the lowest possible cost. Remember, we talked about optimizing cost, so we want to find that lowest possible cost using applied creativity. We want to be innovative in our solutions, try to think of the best possible solution that we can, that meets all our needs. And quality products does not necessarily mean long-lasting product. Again, quality refers to how well does your product meet your customers' needs or requirements. Any questions so far? Okay. So other terms that are used to describe value engineering. So we have value methodology, value analysis, value engineering, value management. These are all terms that are used interchangeably. Okay. So trying to go into a little bit more detail about what value engineering is. So if we were to put it into a function or an equation form, what it would look like is we're going to try to maximize the functionality of our product or service while minimizing cost. So that in the end, whenever your numerator is a larger number, your denominator is a smaller number, you get an overall larger result. So we want to maximize that function or the functionality, minimize the cost. In general, value, what it means is the reliable performance of functions to meet that customer's needs. The function, what it means is it's a characteristic, so something that product or service actually performs. So if you have a storage bin, the function that it performs is to store something. And then the cost is the cost needed to produce the item. So when we talk about value engineering, good value is the lowest cost to reliably provide the required function with essential performance. So the reason why we want to even talk about value engineering is because when we're looking to provide something to our customer, we want to reduce the overall price. Reducing the overall price that product. But at the same time, the reason why we start talking about functionality, so suppose we're looking to buy a car, or let's say make a car. What is the overall function, or what is the purpose that a car is trying to solve for us? Transportation from, let's say, point A to point B. So we just want a vehicle that can take us from A to B, right? And we just need it to drive us there. Now if we think about it, the basic or the essential functionality of a car is to drive us from A to B, or something that we can drive. But when we start thinking about other things that are included as part of features, functionality in the car, such as the radio, the automatic windows, the DVD player, the whatever, those are all added features. Those are not required to make that product work or to make that product actually satisfy its basic need. So what we need to do as an organization is understand what it is that the customer's absolute essential needs are, and build a product that at minimum meets those customers' minimum needs, and anything else is extra. So once we build a product that at minimum meets those customers' needs, the basic needs that the customer has, then what we can do is provide to them a product that is even cheaper than what we may have been thinking about before, and it still satisfies their purpose. So you're able to deliver a high quality product at a lower price because their basic needs are satisfied. So value is always increased by decreasing costs while maintaining essential performance. So essential performance, that's what we're referring to as functionality. So at minimum, functionality is the essential things that the product needs to perform. And value may also be increased if the customer's needs if the customer need, sorry, that makes sense. Okay. If the customer needs or wants more performance, then you can overall increase the value of your product. So it would change because your functionality would increase, your price may increase, but that can overall, since everything is increasing, it may also cause your value to increase as well. Okay. So value engineering, it applies to everything because every project or process has a function. So when we talk about function, as well, we talked about what is the essential objective of whatever product or service we're doing, but it applies to things such as processes as well, because every process also has an end objective. So anything that has an end objective that we're trying to meet, you can apply value engineering to. Unlike concurrent engineering, which has to be applied to the overall organization and requires a lot of organizational restructuring, value engineering does not. And it can actually be applied at any point in the design or process. So you can apply it right at the beginning when you're trying to do your conceptual design process, or you can apply it right at the end while you're actually manufacturing. So there's no rules about where or when it can actually be applied. It's also a problem-solving technique. So with value engineering, once we start looking at, our customers given us maybe 10 different requirements, well, it requires us to go in, really define that problem well, and understand what is it that their real core problem is, and what are the things that are just other things. So it's a problem-solving technique that really helps us get to the root of the problem. And it's also it can be used as a technique for developing design criteria. So again, you want to pinpoint that absolute essential functionality, and you want to make sure that those are the main objectives in your design criteria. Any questions so far? Okay. So why do we actually find, or why do we have poor value? So the first thing, lack of and/or poor coordination amongst designers. So why do you think this is a problem? And why does that lead to poor value? Okay, so we have wrong functionality. Why?
Because all designers should work together
coordination are you saying there's that leads to requirements not being met? Okay, so what both of you guys are saying on the right track. So what happens? So suppose if you two were working on a project together, and you were doing something, and then pass it on to you, and you didn't know what she was working on. So if there's the lack of coordination, are you guys going to be able to build an excellent deliverable? No. So if you don't know what you're expecting from her, and if you don't know what she's actually expecting to get from you, then you have that lack of coordination. You have a problem. You're not on the same page. And for those of you who are in my 5100 class, one of the things we talked about when we talked about brainstorming a couple of weeks ago was making sure that the group is on the exact same page as to what the problem is. What is the problem that you're looking to solve? So once everyone is on the same page, that's half your problem, or half your solution towards solving coordination problems. Everyone knows exactly what the problem is and what they need to do to solve it.
What could be the reason if both people are on the same page, you are getting the good
So you have people on the same page. So you know how last week when we were talking about concurrent engineering, before we talked about the concurrent engineering where you have a bunch of people working together, we talked about the serial or the sequential engineering process where you had one group, then the next, and the next. Well then when you don't if you have one group that doesn't know what they're going to get from another group, there's no coordination, that may actually cause your project to take a lot more time than what it actually needs to take had they been working together. So because of that, you end up spending a lot more money. So your cost ends up increasing, your value ends up decreasing.
I think that two parties are on the same page.
Yeah.
They know what they're expecting. Still they don't make the what could be the reason behind that?
You're not committed
They
towards the
could, yeah, they may not be committed to it. There just may not be good communication between the two people. Maybe they just don't work well together. So I think that becomes more of a HROB type of issue. Okay, so failure to network with customer. So poor definition of needs and wants. Why is that a problem? We talked about this in week 1. Come on.
You're not being connected with them.
Okay, so you need to know what the customer actually wants, okay? So the other thing that's important over here, customer needs change on, like, as time goes on. But beyond that, sometimes you have customers who have business needs and they're just not able to articulate them well. So what you need to do, you really need to maximize your interaction with the customer to make sure you are understanding what exactly it is. The more you interact with them, the more information you have, the more likely you will be able to have a better grasp of what their needs and wants are. What does this one mean? Design based on habitual thinking or mistaken beliefs. Lack of. Okay, so how so?
You're not following any new idea. You're just taking you're following the process, whatever the process is. You're just following that. You're not thinking out of the box.
Okay, so you're not thinking outside of the box. So why does that lead to poor value?
There's no value added.
Okay, so exactly, it's the same thing. So you may be doing, producing an older solution. Maybe that's not even the most cost-effective way, but again, you're not being innovative, you're not really adding value. Okay, not enough time for project formulation and design. What's that?
You just start to go ahead and implementing things right away. You start figuring out what you need.
Okay, so how?
You just start building stuff for your sure you need. So you go to the order and the only product provides the value to your customers. Start adding the systems and the systems where you need.
Okay, perfect. Okay.
And I hope that
when we talked about project management is you really want to have a well thought out plan before you start acting on it. Because once you start acting on it, like Ken just mentioned, and that's not really what you want to do, you end up wasting a lot of resource time, but you also end up wasting a lot of money as well. And the last thing, failure to utilize the latest technology. So at the same time, you know, it ties in with this thing, design based on habitual thinking or mistaken beliefs. So you have people who are repeating the exact same designs that they've been using forever. However, as time evolves, as technology evolves, you want to start incorporating newer and newer technology into your solutions. And again, incorporating that latest technology helps to deliver more value to your customer. Why? Because you have a product that has more functionality and will last a lot longer. So overall, costs will be minimized because the overall life cycle may last you a lot longer than an older product. Any questions on this before we move on? Okay. Sorry, there's one last one. Negative attitudes. So why is that a problem? So there's that. Anyone else? Okay, so in general, what we mean by negative attitude, so, you know, you're not willing to change, etc. It also leads to a lot of, you know, it leads to your team being demoralized. You know, if someone is not really motivated, doesn't really want to be there, they're not really going to put all their effort into maybe developing the best thing that they could be doing. In that case, you're decreasing the overall value of your product because you may not be getting the functionality or the results that you can hope to get, and in the end you'll probably end up paying more money because this person may take a lot longer to do what it is that they have to do. So that negative attitude in the end affects the overall value of the product that's being delivered. So other reasons for poor value, just go over these really quickly, we kind of talked about them. Poor communication in developing project scope. So again, remember the scope is one of the first things that we want to talk about. So scope helps us kind of put boundaries around what our problem is, what we're looking to do. So if we don't have boundaries on that, then we may be solving a problem that's not actually there. Again, lack of consensus amongst project stakeholders with regard to project scope. So sometimes you have people who are on different pages about what this project or what this product is supposed to do. And when they're not on the same page, again, you end up solving a problem that you don't really need to solve. Outdated, inappropriate design standards. Fixation with previous design concepts ties directly into using like the habitual design process. Honest wrong beliefs. So that actually is an honest mistake that someone may have. They may have misunderstood something. They may believe something to be a certain way, but just not know any better. So that is also another reason for delivering poor value. So there's a couple of common misconceptions. So when we talk about value engineering, and if you're talking to, let's say, somebody in maybe a manufacturing company or maybe any other type of engineering company, and if you ask them, do we do value engineering? Many people say it's something that we do all the time. But at the same time, that's often a common misconception. So value engineering in general requires the application of a specialized body of knowledge at the right time with the right people. There's a certain process that needs to be followed. Like I mentioned before, take a look at, if you're interested, the SAVE, the Society for Advanced Value Engineering website. You'll find a lot of useful information on there. A lot of people believe that value engineering degrades project performance. However, if it is applied properly, it should actually efficient, a lot more effective. You'll start doing things the way they should. It's not just another management fad, and it's not cost cutting either. Okay, so just so you guys understand the difference between, say, value engineering and cost cutting, value engineering in general, the overall goal is to maintain or improve performance while reducing the total overall cost. So remember, we want to minimize life cycle costs. Cost cutting in general is more of a reactive measure that organizations, project teams, what have you take in order to respond to a certain situation. So now suppose management decides to cut your project budget by $10,000. Well, one of your cost cutting measures that you may take is to take a resource off your project. Is that really a planned activity, or is that a reactive activity? So, and when you're cost cutting, because it's more reactive, it's done at the expense of project quality. However, when it's planned, it's a planned allocation of time and effort, you're not going to compromise your quality at the same time because you are expecting a certain thing to happen. Value engineering is a highly structured process using a formal methodology process. So the value engineering process ties very closely with the project management process. So it's very, very structured. Cost reduction, again, very reactive, very informal. Cost reduction generally involves only a few management personnel, so people who are making the decisions about budgets are being cut, how are we going to save a certain amount of money. Whereas value engineering, similar to project management, requires a team who has people from different backgrounds. And then value engineering requires follow-up, implementation, reporting to make sure that it's actually being done properly. Cost cutting doesn't. So once you cut costs, you generally cut it, and you don't really go back to see what is the impact of what is being done. Okay, so value engineering in general, tool, methodology to enhance overall quality. So if we're looking at timing the value engineering effort, what we see in general, if we were to make a change in our project, it's very easy to make a change right at the beginning because the cost to make a change to your overall project is very low. If you start making a change before a lot of the design has been finalized, before any of the manufacturing has been done, the cost to change, very low. But however, the further you get into your project, so once you start the implementation of the manufacturing or whatever, the cost to make changes increases exponentially. The potential savings that you can bring to your project too, based on the methods you implement or based on your process, is a lot higher at the beginning. So if you're a lot more efficient right at the beginning with implementing good process, knowing exactly what you have to deliver, maybe implementing value engineering, your potential savings increases. And if you implement value engineering, let's say right in the planning phase of your project and decide to continue it throughout, your savings will increase dramatically right at the beginning. Any questions on this? Okay. So there's 6 phases in the value engineering process. I'm going to go over them fairly quickly. The first is the information phase. So a lot of this is going to tie back into that systems engineering life cycle. So the information phase, again, is similar to gathering your customer requirements, that initiation phase, conceptual design, whatever you want to call it. So basically, you're trying to gather information to better understand the problem at hand. Functional analysis, again, we want to understand that project better. We want to start clarifying the required functions. And we're going to talk more about the functional analysis phase in a few minutes. What we have in the creative phase, so again, up with several viable alternatives to solving our problem. So in this creative phase, what we're trying to do is generate ideas on the possible ways to accomplish the required functions. The fourth one, the evaluation phase. So remember, once you come up with various alternatives, we want to start evaluating them. So we want to build some sort of criteria against which we're measuring our alternatives to decide which is the best one, which one should we proceed with. Finally, the development one, you choose what your best solution is and you start to develop it. However, when we're talking about value engineering, instead of right away starting to proceed and develop that solution, what we want to do is something called the presentation phase, which is present our proposed solution to our stakeholders to make sure that everyone is in agreement with the approach we're taking. Any questions on this? Okay. So the information phase, again, whole point is to determine user needs, gather information concerning the item, to build team knowledge. Like we talked about, if in an earlier week, if a user or someone who's working on the project doesn't have familiarity with that project, problem, whatnot, one of the things that's strongly encouraged is to visit the site and then to get a sense of what the problem is, how it works, and how things need to be. And you basically throughout the overall course of the life cycle, you want to continue to gather information. Okay. In terms of techniques on how to do that, so you want to get facts from all the possible sources. You don't want to just talk to the management team. You want to talk to the design team. You want to talk to as many people as possible to maximize the amount of information you're actually getting. You want to develop cost models. So again, this is all related to the LCC stuff, cost optimization. So what we want to do, we come up with our different designs. We want to evaluate them based on cost to determine which is the best solution. We want to prepare something called a FAST diagram. So we're going to talk about that again in a few minutes. This is actually a really interesting diagram to help us pinpoint the main functionality of the system. And then finally, we want to identify and define project performance criteria. Okay. So moving on to functional analysis. The reason why it's important is we always want something, but we can't always get exactly what it is that we want. So you can't always get what you want, but if you try, you may end up getting something that you actually need rather than what it is that you want. So what you need is very different from what it is that you want. Your need is your basic functionality you're looking to meet. Your want is something completely different. So functional analysis, what it does, it defines the user's needs through something called verb-noun pairings, and we're going to spend a few minutes talking about that. So the reason why we're going to be specific, and we're actually going to start pairing words together in terms of verbs and nouns, is so we can really pinpoint exactly what it is, or what exactly the function is. So the function basically means a specific purpose or the intended use of an item. Okay. So when we look at FAST diagrams, what we see is various verb-noun pairings, and I'm going to give you an example on the next slide. So what those verb-noun pairings should do is tell us how we plan to solve the problem and why we plan to solve using the solution that we do. So the whole point point of it is to show specific relationships of the functions with respect to each other and to really deepen the understanding of the problem that needs to be solved. So if we take a look at this, for example, so what we have here is we have a steel storage tank, right? So we can use it to store anything. Let's suppose it's gasoline, whatever other liquid. What we have here is an anode. So that anode is almost like a safety switch. So if something happens, this anode, will be triggered, and yeah. So we have a steel tank whose purpose is to hold something. And then what we have here is the excavation and backfill. So it's an area that surrounds the tank that may be filled with cement, etc., to prevent any leakage. So if we start talking about verb-noun pairings related to this diagram, or actually before we get into that, let's identify the function of each of these components. So what we have here, that anode, the function of the anode is to protect the tank. So again, verb-noun pairing. The verb protect, it's an action. The tank, the item, the noun. The purpose of the storage tank is to store the fuel. So again, verb, to store something. The fuel is the what, the noun. And the purpose of this backfill is to hide the tank. So again, another verb-noun pairing. So everything that's in this system, we have 3 units that are in the system, 3 components. Each one of them has a core function, and we're able to define that function very simply using verb-noun pairings. So again, if we look at maybe different things that are involved throughout the overall, let's say, value chain of obtaining fuel, one of the things that we can talk about is to store fuel. So that will be something that we call a primary function. What is the main function of a certain system? So the function of a certain system may be to store the fuel. That would be maybe the system that we just talked about. So when we talk about store fuel, if we are given, this is the primary function that we're looking to solve, we can start brainstorming ideas on how we plan to do it. So we know we want to store something. Now, we can store fuel in what? So we can say, we can store things in tanks, in bins, in silos, in whatever. So this starts helping us to brainstorm possible solutions to that particular problem. If you want to obtain fuel, again, we want to start thinking of how can we get the fuel. So can we manufacture it? Can we purchase it? Can we recycle it? Those are all things that we want to, or that, again, you can brainstorm to think about how you can obtain fuel. Dispense fuel. So again, how we want to dispense it. So what are the different methods that we have? So brainstorm another list. We can pump it. We can use a conveyor, a cable, a microwave. Those are all different ways to provide that primary functionality. Any questions so far? Okay. So what we have next is something called the creative phase. So the creative phase touches on what we just talked about, which is the brainstorming bit. So overall, the entire purpose of brainstorming is to generate a large number of alternatives that provide that item's basic functionality, so store fuel, dispense fuel, whatever, without actually considering their practicality. So again, those in my 5100 class, one of the things that we did as part of that brainstorming exercise that we did in class was to suspend judgment on those different ideas that people would present to that problem we were trying to solve. So the reason why you want to suspend judgment is so that you're actually trying to encourage the maximum number of ideas. You don't want to say, suppose you come up with an idea and you come up let's say you come up with a certain idea, and you listen to our idea, and you come up with another one, and let's say your idea is completely ridiculous. So you don't want someone saying, no, that's not going to work, because that's going to stop that flow of creativity. You want to suspend the judgment until that brainstorming phase is over and you start to evaluate those ideas, because this starts to maximize the number of ideas you'll actually get. And the reason why you don't want to consider the practicality is because sometimes when you're not thinking about how practical a certain solution is, it helps to be more creative, come up with better solutions. If you start to restrain yourself to think about, is this actually feasible, is it not, then you're holding back. So speculation phase, also known as a creative phase. So again, no rules, no limits. You don't want people to control your thinking. You don't want to judge people's ideas. What you want to do once you have a list, you want to start to group them together. You want to eliminate the ones that may not work, but once the brainstorming phase is actually over. You want to maybe start combining different alternatives, different ideas together, so you can come up with one better idea. You want to try to build upon other ideas that have been discussed. So all in all, the whole point of that brainstorming or that creative phase is to bring about change, to figure out better ways to do things. So again, no criticism. Combine ideas, build upon other people's ideas, etc. And jot down all ideas, because sometimes something that's a good idea now may not be feasible now, but may be useful later on. So you want to make sure you note those things down. So there are no dumb ideas, some are. Okay, so that leads us to something called the analysis phase. So once we've generated our various ideas, we started to group things together, we want to start to evaluate those thoughts. We want to criticize them, we want to rank them to see what is feasible, what is good, what should we move forward with, etc. We also want to identify the advantages and disadvantages as compared to the baseline. So as compared to their current solution, or as compared to what we need to be providing. So we want to take those ideas and look at what are the advantages it's going to provide, what are the disadvantages. We also want to talk about what alternatives give the best combination of something called designability, constructability, operational ease, quality assurance, customer satisfaction, and low life cycle cost. So again, when we're thinking of, or when we have different ideas, we want to make sure that it considers all of these, not just one of them, because we want to overall end up with a solution that is, the best possible design. So the easiest to construct, it's easy to use. So you're trying to think about your stakeholders from all different aspects of your product life cycle. So the designers, the people who are constructing it, the people who are using it, who are going to be maintaining it, quality, etc., and your overall customer. And finally, you want to minimize the cost. So it's a lot of things to think about and balance at the same time. But that's the reason why you really want to take advantage of the brainstorming phase and go back to it as many times as possible, so you can really come up with the best solution. It's one of the things that Toyota did in the case study. So before they ended up finalizing their design, they went through multiple brainstorming processes so they could come up with the best possible solution that was designable, constructible, all of this stuff before they went ahead and actually implement it. So again, to generate alternatives that offer the greatest increase in value. Okay. So when we're analyzing different ideas, what we want or what's important to have, or different techniques, prior experience with it. So sometimes you have people, or people who are brainstorming different ideas. Maybe one person has experience with a certain, with a certain path. That definitely helps with analyzing it to see how feasible, how designable, constructible it actually is. Collective gut feeling. So inner tuition, always listen to that. Stakeholder input. Again, stakeholders also refers to your customer, it refers to other people who have decision-making influence on your project. You do want to hear from them, and you want to consider what their thoughts are on the solution or the ideas you're proposing. Cost references. So what that refers to is, suppose you're building something and it's something that another company is building, a similar product or service. So you want to reference the cost, if possible, if you're able to obtain that information, to make sure that you're doing things at least at the same level in terms of efficiency, in terms of effectiveness, cost-wise, or are you doing better than that? So you want to have some sort of baseline. Apply matrix technique. So again, this sort of refers to what we talked about in week 3. So remember, as part of that issue formulation phase, we had a bunch of objective criteria that we were looking to meet. And one of the things we wanted to do was talk to our customer to understand what it is that's priority to them so we can rank things accordingly. Well, that's part of what this matrix technique is. It's not just one technique, it's multiple, but you want to really define what are those performance measures, what is it that our customer wants. So what's going to define performance to them? You want to weight and rank your measures. So what is the most important thing? So again, if we're looking at, let's say, cell phones or laptops, is it battery life versus the weight, or battery life versus functionality? Those are things you want to maybe rank. What is more important, and which one are you willing to compromise on? And finally, once you have all your different measures listed to you, you want to evaluate those alternatives and again pick your best solution. Make sketches. So part of this whole analysis phase may involve you building prototypes. Sometimes you don't get to do that, or sometimes you don't get that far. But making sketches, so drawing out what your proposed solution is, how things work together, how things integrate together, that's important to do. Consult experts. So again, sometimes there's people beyond our organization that have a lot more knowledge than us on a particular topic. So getting their ideas, getting their thoughts, their expertise will add a lot of value to your overall project that you're working on. And use your own judgment. Again, all of this refers to good human relations. So again, effective communication skills, which is extremely important throughout this whole process. Okay. You also have to consider life cycle costs. So we talked about life cycle costs just before the midterm. So remember, when we're looking to optimize costs, we want to minimize the amount of maintenance that our product is going to have. We want to minimize the amount of service costs. We want to minimize, we want to maximize the salvage value. We want to minimize the initial investment. All of these things together are referred to as the life cycle cost. And what you want to do, you want to minimize it. So LCC, we've already talked about it. Initial cost, ownership cost, salvage value, disposal cost, those are all things that together make up LCC. Okay. What we can do next, once we have our ideas, we select the best alternative. And that's the whole purpose of the development phase, which is the 5th phase in the overall value engineering life cycle. What we also want to do, we want to develop written and oral proposals, because remember, the last phase in the overall value engineering process is to communicate your idea to your stakeholders. be able to present your idea to them. And the reason why it's so important to have good communication skills, not just as a manager, but as an engineer as well, is because you want to be able to communicate your idea effectively to whomever you are talking to. Okay. So when we're talking about presenting our idea, we want to be very specific about what it is we're talking about. We don't want to be general. The more general we are when we're presenting a certain idea to someone, the less likely they'll actually be convinced of that solution that we're proposing. So we want to be very specific. We want to make sure that whatever it is that we're presenting addresses all their concerns, their needs, etc. very specifically. When we're looking to sell a solution or even propose a solution to a group of stakeholders or the customer, we don't just want to talk about the benefits of our solution, we also should mention what are the disadvantages. Because the disadvantages are things that the customer is going to have to deal with. However, if they are made aware of them early on, they're able to plan for those those things accordingly. So you want to make sure that you talk about both things. General business practice, it's good to talk about your disadvantages to a certain extent. You probably don't want to list off all of them, but you want to make sure you bring up some, because a company that generally doesn't talk about any of their disadvantages, it does seem like they're hiding something. So you want to be balanced in what you're presenting. You want to gather convincing data. So not only about your solution, not only about your customer needs, but you want to be able to gather information about, let's say, technology trends, industry trends, etc. All of those things together help to really prove your point. They help to assure technical adequacy. So are you, is your solution technically strong? This one's key, and many people who work in, let's say, larger organizations, or many managers of larger organizations don't seem to agree with this one. Spend your client's money as you would your own. So just because they're the client doesn't mean that, you go and you charge them a ridiculous amount for a certain product or service. So what you want to do, you want to spend it as if it was your own. So suppose you're building a solution that you don't believe in, that you don't believe that this is good value for that price. Well, why should the customer be convinced that it's good value for their money? So you want to spend your client's money as you would your own. So if you know that you would buy, let's say, a certain product because you think it's the best and you'd be willing to invest in it, think about things, or when you're building a solution, think about yourself. Would you be willing to buy the product that you're actually making? And then you want to prepare your proposal. So you want to finalize that fast diagram. So the reason why that fast diagram is actually so important is because once you're able to build your solution and you have mapped out the different components that are part of your solution, you're able to really describe their functionality in a simple way using a fast diagram. There's one specific function for every, let's say, component in your system, and you're able to define it in a way that makes sense to most people. It really helps to simplify the explanation of your system. So suppose if you're explaining your design to someone who's not technically strong, someone who does not have that background, once you use things such as a fast diagram, they're able to look at it, they're able to understand it very simply. And sell the idea using justification. So why is it that they're buying it? And keep in mind that you're selling something that is uncomfortable to most people. So the reason why it's uncomfortable is because they don't know a lot about it. So most people are not comfortable with change. Okay. You want to minimize, if possible, the amount of mistakes in your proposal to the customer, because the more mistakes there are, the more that starts to cast a doubt on your validity as a company. good interaction with the customer, good communication skills, etc. Any questions so far? Okay. The last one, the presentation phase. So the whole point of it, we talked about our proposal that we're going to put together. We want to now present this value engineering study. So we've now talked about our system. We've talked about determining what are the exact functions that our system is going to provide. We've talked about simplifying our system so that it provides the absolute basic functionality to a customer. And what we want to do, we want to present the value engineering proposal to the decision makers, the stakeholders, so that they will hopefully be convinced of whatever it is we're proposing. The whole point of the presentation phase is also to obtain approval or support. So sometimes you have to go through different levels of approval before someone agrees to purchase your solution or someone agrees to the change you're making. That's another aspect of your presentation. To enhance potential implementation. And how do we actually do all of this? So again, keep in mind that we are trying to sell change to another organization or within our organization. You have to be enthusiastic about what it is that you're trying to sell or deliver. If you're not enthusiastic about your product or project, if you're not convinced of it, if you're not convinced that it actually does what it does, you're never going to be able to convince someone else of that either. So make sure you're enthusiastic. So this also ties back to the point we talked about before, that negative attitude. So negative attitude helps to decrease value. So again, the more enthusiastic you are, the more positive you are about things, helps to overall increase the value of what it is that you're working on. Again, use that fast diagram as some sort of communication tool. So what you want to know, or what you want to be able to show, is that the most important functions that the customer had in their requirements, that they're satisfied. So again, by using that type of diagram, being able to pinpoint specific components within your solution to say that this particular component satisfies a certain need, etc. This helps to explain that very simply. Be brief, be convincing, keep it simple, and anticipate the other person's point of view. Again, keep in mind that you can't make everyone happy, and do not overload them with too much information. Okay, so on that note, I'm going to end the lecture portion of it here. What I am going to talk about, let's take a break for 10 minutes. I'm going to talk about the Toyota case study next and review the questions which I asked you guys to work on over the week.